Okay.
Okay. Good evening. I'm Mark Clevey. I'm your host for tonight's Renewable Energy Seminar. Tonight, we're going to have a very interesting talk about carbon sequestration. Is it a worthwhile solution to meet the carbon budget or just another big oil stratagem? Good question. And the person who is the best to answer that question is Janice Means. She's a professor emerita from Lawrence Technological University and a member of the board of directors of the Great Lakes Renewable Energy Association. Our financial sponsors for this series continue to be the Michigan Department of Environment and Great Lakes, EGLE. Great Lakes Renewable Energy Association was formed in 1991. It's a 501c3 nonprofit organization supported by members to educate and advocate for renewable energy in Michigan. You can learn more about GLREA membership opportunities at www.glrea.org. If you're not a member, we invite you to do so. If you are a member, we invite you to get every member of your family to join it and only give this out as birthday presents for the next 5 years. Janice K. Means is a PE, LEED, AP, FESD, FASHRAE, and Professor Emerita, Lawrence Technological University. She is also a board member of the Great Lakes Renewable Energy Association and a GLREA Outstanding Woman in Solar awardee. She is also an ASHRAE Fellow and a life member with numerous ASHRAE awards, an Engineering Society of Detroit Fellow, and a 2021 Gold Awardee for Outstanding Engineer Scientist. In November, she will be inducted with a very prestigious Michigan Women's Hall of Fame for her work in sustainability. On a personal note, Janice and I go way back in the 1970s when we were both much younger, and she was telling me we weighed a lot less, and we both served on the board of directors of the Michigan Solar Energy Association. The important part about that group was that they were instrumental in getting the first Michigan solar tax credit enacted. I looked all over today. We actually have a picture of Janice and several of the founding board members, standing behind Governor Blanchard as he signed that important legislation. I believe Governor Engler was the one who murdered that legislation. Somewhere there's a picture of him with a whole bunch of people bearing axes.
To return the favor. This will be the
Janice will
series of appearances for Obama in the final stretch of Harris's campaign.
Whoever
has already drawn a lot of comparisons.
Whoever's watching television, please turn it on. Thank you very much. Janice will be presenting an overview of carbon capture and storage, or carbon sequestration, and its potential role in meeting the carbon budget to keep the Earth's temperature rise under 2 degrees centigrade. Relevant to this presentation, Professor Means was a co-author of the climate change chapter in the 2021 ASHRAE Handbook of Fundamentals and Handbook Chair for the updated chapter to be published in 2025. She is also the co-editor and co-author of the 4th, 5th, and 6th editions of the ASHRAE Green Guide, Design, Construction, Operation, and Sustainable Buildings. And so it is my great pleasure to welcome fellow solar enabler, Janice K. Means. Janice, it's all yours.
Thank you, Mark. I'm sharing my screen.
And I'm trying to stop mine. Stop video.
And hello, everyone. Let me get rid of my floating. There we go. Okay, today I'm talking about carbon sequestration, a worthwhile solution to meet the carbon budget, or another big oil stratagem. Some of you are probably wondering what stratagem means. So I've actually looked it up for a definition. And according to a Google search on it, it's a plan or scheme, especially one used to outwit an opponent or achieve an end. Okay, so under acknowledgements, I want to stress that carbon sequestration is considered to be in its infancy by some, by others, but through some technologies, it's not. It first was explored in the 1970s. As late as 1999 was when direct air capture was started. But the oil industry has known that injecting carbon dioxide to push out more product from the ground, they've known this for decades, and they have used it for decades. Okay, I also need to let you know that I'm a student of carbon sequestration. I do not claim to be an expert in this area, but I'm learning, so I'm going to share with you what I have learned over the last several months on this. After this conference, or excuse me, after this session, you should be able to state the IPCC's view of the need for carbon sequestration to meet the carbon budget versus the oil and gas industry view to allow more product, list 3 ways that the Earth's natural systems already capture and store carbon dioxide, name and describe at least 3 different technologies for accomplishing carbon sequestration or the capture and conversion of CO2 to useful products, and name 3 places where CO2 could be stored, and finally contrast the benefits with the cost of sequestration. So I'm starting with an introduction where I go through some definitions for you and then go right into looking at the IPCC's view versus the oil and gas industry's position on carbon sequestration. Then I go into augmented natural carbon sequestration. Ever since Mark, when we were first talking before this, said he was having a hard time pronouncing sequestration, now I'm having a hard time pronouncing it. Anyway, other carbon capture and storage strategies, transportation and storage of CO2, cost and feasibility of carbon sequestration. Finally, I'll have a summary, and then I have a few slides with recommended sources about carbon sequestration and talk a little bit about what's happening in Michigan. So let's start with the introduction. So carbon sequestration is not well understood by the public, and if you look through the mass media, even through some of the technical areas, you'll find a lot of different definitions for it. There are also many different terms involved in it, and it's a bit of an alphabet soup in figuring out what's what. I'll try to guide you through some of this, although I'm not going to go through every single technology, and we don't have time to go into exactly how they accomplish these, but I do give you some general idea. Natural, anthropogenic, there's a term for you, it means human caused, and anthropogenic assisted natural processes and technologies are part of carbon sequestration. Is it cost prohibitive, or is it something that we have to do? This is something that's being explored. It's a contentious topic, all right. Is it a partial solution to our climate change, mitigating climate change? Or is it a way for oil and gas companies to sell more product? Maybe it's a little bit of both. We'll see. I'll leave it up to you. I'm going to start with the carbon cycle. And you can see in the carbon cycle, this is the atmosphere, of course, and millions of years ago, most of the CO2 came from volcanoes, and that's when the carbon dioxide was very high in content, and so were the temperatures of the Earth. Right now, about 1% of the CO2 in the atmosphere comes from volcanoes. Other sources come from animals and people, and also a little bit from the oceans, although the oceans mostly hang on to it. I'm going to address what humans do in just a moment. Of course, plants use CO2 with photosynthesis and give off oxygen. Animals animals and people eat the plants, and people eat the animals too, and give off CO2. And so do wetlands absorb some of the carbon dioxide, and as plants and animals decompose, they become sometimes they turn into oil and gas, the fossils, and all of that sometimes is then released eventually. Okay, there are the human costs of right now, which is changing this atmosphere. For 800,000 years, there was 280 to about 400, or excuse me, 280 to 300 parts per million of carbon dioxide in the atmosphere. Once the Industrial Revolution started with the fossil fuel emissions and changes in agriculture, or the work with agriculture, especially tilling of the soils, and now with transportation, more and more CO2 has been emitted into the air. So instead of having that under 300 parts per million, we're now at about 420 parts per million. So let's go. Let's look at the definition of I'm sorry, a carbon sequestration, you're going to find, as I said earlier, it's defined a lot of different ways. If we look even at our US government, there are different definitions. The Agriculture Forest Service defines it as a natural process where atmospheric carbon dioxide is taken up by the trees and the plants and grasses, excuse me, all of that. Whereas the Geological Survey describes it as an anthropogenic process, where it's the capturing and storing of atmospheric carbon dioxide. But there are several processes and technologies which, for this presentation, we're going to refer to collectively as carbon sequestration. Okay, the broadest term that I have found in the literature for anthropogenic carbon sequestration is carbon dioxide removal, CDR. So it was what has to do with removing carbon dioxide, again, from the atmosphere. That's the EPA's definition. Now, the IPCC's definition, and I tend to go more with the IPCC definitions, is that it's human-caused removal of carbon dioxide from the atmosphere, but also durably storing it. Okay, so that's carbon dioxide removal. Now we have carbon capture and storage. And this actually, I like to think of it in terms of having a stream of material, either from industry, from energy, where the CO2 is separated from the product and then it goes to storage. So that's the definition for that one. Also, it's interesting to note in the 2022 IPCC report, they use the term sequestration only for the enhancement of natural sinks of CO2. And I bring that up just to tell you that, or let you know that this term, carbon sequestration, is used in a lot of different ways. Okay, here's a third term I want you to really know, or maybe the fourth if you count carbon sequestration, carbon capture and utilization. And this has to do with the making, the capturing of CO2 and then making a product out of it or several products. And one example is taking CO2 and creating hydrogen and solid carbon, both of which can be sold then. Just to keep you not too confused on this, I created a little table. These terms, the CDR, carbon dioxide removal, the carbon capture storage, carbon capture and utilization are all anthropogenic, but here's the difference. Carbon dioxide removal, it removes CO2 from the atmosphere and durably stores it. Carbon capture and storage, it separates CO2 from a product stream, transports it, and durably stores it. And the carbon capture and utilization removes the carbon dioxide and creates a product from it. And many of the technologies that come from this come really from these three terms. These are the general terms. So why is the anthropogenic carbon sequestration being pursued? Well, it's being pursued for two basic reasons. First of all, it's a way of meeting something known as the carbon budget, which I will be defining in a minute, and also for a method of pulling more oil and gas products out of the ground. I didn't hear any boos, but I know. Howard Kozak, who is a senior research engineer for MIT Energy Initiative and coordinating lead author of one of the IPCC reports, says that many people, quote unquote, many people think of carbon capture as a fossil fuel technology. I strongly disagree with that perception. More than anything, carbon capture is a set of technologies for addressing the problem of climate change. He wrote a book, which I have read. I thought it was an excellent book called Carbon Capture, which really goes into great detail on the history and also the details of the different things going on. I have this quote in here because, like I used to think, many of you think of carbon sequestration as just getting more oil out of the ground. but there's a lot more to it than that. So that leads us into the IPCC versus the oil and gas industry's position. So what is the IPCC's position? They say that, quote, it is a key element in scenarios that limit warming to 2 degrees or 1.5 degrees centigrade by 2100 and is therefore necessary to achieve net zero CO2 and greenhouse emissions both globally and internationally. And they do comment on carbon capture and storage and carbon capture and utilization of the CCS and CCU, which I just previously defined. And they say that those are normally applied to fossil fuels, so they don't count as removal technologies. Everyone hear that? The only exception is if the CO2 is what's called biogenic, which means it's produced by living organisms, or it's directly captured from ambient air and stored durably. Okay. So let's look at the carbon budget. And there's no real precise way that they can tell us what we need to remove because we have no way of knowing in the future how much CO2 or greenhouse gas emissions that we are adding. Right now, it's thought that we have 22,590 gigatons of carbon dioxide in the atmosphere. And they've estimated how much must be removed using carbon sequestration in order to reach 1.5 degrees centigrade in 7 years, 1.7 degrees, or excuse me, degrees centigrade in 15 years, and 2 degrees centigrade in 28 years. And this is all based on a 50% likelihood. You will see different numbers on this. And I also thought I would remind you, those of you that aren't familiar with centigrade, 1.5 degrees centigrade is equivalent to 2.7 degrees Fahrenheit. The Earth right now is about 2 degrees hotter than it was in pre-industrial times. And if you look at Michigan, the northwestern part of the mitten actually is up to about 3 degrees warmer. 1.7 degrees Celsius is 3.06, that would correspond to this middle one, and 2 degrees Celsius is 3.6 degrees Fahrenheit. Now, you see these numbers here, 275 gigatons that have to go out. But look at this, just in 2022, there were 57.4 gigatons of CO2. And the E here, by the way, means equivalent. So it's all of the greenhouse gases, not just carbon, although carbon is the major one on it. So it's not going to be easy. Although our rate of the Earth emitting, or humans emitting, the CO2 has slowed up, we're still emitting more and more each year. It did go down during the pandemic for 1 year. Okay, so what's the oil and gas position? I think you already know that. They publicize that they're actually helping in meeting the net zero goals. They also try to reassure the public that they're really, not adding more CO2 to the atmosphere, but really they're creating more product, more fossil fuels, which are then burned that do give off more CO2. Okay, so let's talk about augmented natural carbon sequestration. And that really has to do with augmenting or helping with what are called negative emissions technologies, or NETs. So we have another definition here. These are activities or mechanisms that result in removal of greenhouse gases from the atmosphere again by deliberate human activities, but it's in addition to the removal that would naturally occur. Okay, so what are these involving? The first one is called afforestation and reforestation. And this is when, for reforestation, you plant trees in places where they've all been cleared away, where there used to be a forest. Afforestation is planting trees and plants where they didn't exist before. No-till farming. Why is that important? Because the soil, which I forgot to mention when we were going through the carbon cycle, soil retains CO2. But when you till the soil, it loses, or the CO2 escapes into the atmosphere. Conversion of biomass to biochar added to the soil. So you burn biomass, wood, for example, and then you add it to the soil. Of course, you're going to lose some CO2 here, so you have to have some way of reclaiming it. Adding iron to the ocean. This has become a little bit controversial. They're not sure if it may affect the ocean animals and flora and fauna there to some degree, but it is one of the negative emission technologies. Moving right along, we also have something called enhanced rock weathering. And in order to understand that, we first need to understand what natural rock weathering process is. So let's look at that. There's CO2 in the atmosphere, and the moisture of water, okay, in vapor form in the atmosphere forms to make actually an acid. This is what causes, I can't think of what it's called at the moment. But it forms acid rain, okay? And that carbonic acid, that's it. Carbonic acid comes down, and especially when it falls on calcium rock, there is a chemical reaction, and you end up with calcium ion and bicarbonate. Well, these rocks then break down, and eventually it goes into streams. The bicarbonate washes down, and then it there again goes through a chemical reaction to form CO2 and water in the ocean, and the ocean then takes the CO2 and sinks it. It weighs more, so it sinks to the bottom and it's safely sequestered there. So what is it? How does it work when it's enhanced rock weathering? Well, what they do is they take rocks and they crush them, okay, and then spread them across soil, or they use mining waste, and they're careful not to use any mining waste that has any heavy metals in it. And that works. It also enriches the soil and is supposed to make it easier or better for farming. There's also bioenergy with CCS, carbon capture and storage, if you recall. So everyone knows that plants use the sunlight to create photosynthesis, and they give off oxygen, and then the animals eat the plants. Well, the animals and the plants then form biomass, which is described here, some of the examples of biomass. And then if you convert the biomass to the energy again by burning, or you can convert it to actual fuels. And there are three ways that this can be done: biologically, chemically, or thermochemically. And I'm not going to go into the details, but you can create fuels from them. So the CO2 is then captured from the power plant that's using the biomass fuels. Direct carbon capture. Okay, I'm starting to talk about some of the other carbon capture and storage strategies. DAC, this is a process where you have fans where the atmospheric air is pushed through fans, and the CO2 is either absorbed or adsorbed, meaning it's either absorbed like you can think of a towel, a paper towel absorbing water. That would be absorption with a B, or it's adsorbed with a D, meaning that the ions, or excuse me, the CO2 then adheres to a surface, and then they have ways of getting it out. So basically, it's using a stream of air to do this. There's also direct air carbon dioxide capture and storage, and it's spelled both with a CCS or just a CS on it. And all that is it includes it includes the storage along with the capture. There's some very interesting things happening with that, by the way. I had wanted to go to Iceland this summer, and had intended, if I went to go and look at one of the direct air capture facilities, but it didn't work out. Anyway, Let's talk about oil and gas industry related carbon sequestration technologies. So there's the integrated coal gasification combined cycle, which is called IGCC. And basically, this is easiest to understand if we look at the normal combustion process. Coal is burned with enough combustion oxygen so that it not only gives off heat to run generators, but we also end up with carbon dioxide and water, okay? If you heat the oxygen when you're burning the coal, you end up with something called syngas, which is just carbon monoxide and hydrogen. And of course, hydrogen can be used potentially for a fuel for planes, for example. There's also the enhanced oil recovery using CO2, and this is sometimes referred to as a tertiary amount because they have a tertiary procedure because they have two other procedures that they use for getting oil out of the ground. This one, they take typically carbon dioxide that comes through to the point where they're going to use it from a pipeline. It's injected down into a reservoir. It then combines with the oil and helps the oil then be pumped out. So let's talk a little bit about transportation and storage, and I'm not going to spend much time on this, but transportation, of course, can be done by trucks, pipelines. Pipelines is being a big one, trains, but there's a lot of concerns about what happens if there's a leak from transportation sources. There's also, it can be sequestered by injecting into geologic formations, injecting it into deep levels of the ocean, and there's some controversy on that. I had read earlier that a couple of years ago that they weren't doing that anymore. And more recently, I read that the UK is already injecting CO2 in deep levels of the ocean. It's also mineralizing it into rock. And the direct air capture project going on in Iceland is very interesting because it's not only using the energy from geothermal to power the whole procedure, they also are injecting the CO2 into basalt deep in the underground, and it's turning into a solid, which is very well secured. The other is converting it into a product. Again, there's some concerns that CO2 could leak from some of the storage areas. So there's still some work that needs to be done here. So what about the cost and feasibility of carbon sequestration? If we look at it very long, you don't have to look at it very long to see that it's a very expensive thing to do. So how expensive is it? We're going to look at that. But here are some things that you need to know before we do that. Cost estimates I'm going to give you are in American dollars per ton of carbon dioxide. And 1 metric ton of carbon dioxide is equivalent to 2,204.6 pounds. And it's typically cited as TONNE for the ton. I'm just using the shorter version right now, but do know that this is a metric ton we're talking about. This is important to know too. On average, each American produces about 2 tons of carbon dioxide annually, each person, okay? And it takes 1 billion, that's with a B, metric tons to equal 1 gigaton. And 1 metric ton is equal, or 1 MT is a lot of way they always say it, is equal to 1 metric ton. But as I mentioned previously, in 2022, nearly 60 gigatons of CO2 were emitted into the atmosphere. So it's important to remember these numbers when you're looking at the expense and how much each ton can come out, or each ton would cost. So these are estimated cost ranges for carbon capture and storage, CSS, and carbon dioxide removal, CDR solutions as of 2023. Carbon capture and storage, they give a range of between $15 and $130, per ton. Now, when you start talking about gigatons, It's you multiplying this by a lot. Direct air capture and storage, $100 to $345 per ton. This is the most expensive way to do it. Bioenergy combined with carbon capture and storage, $15 to $400. Forestation, reforestation, $5 to $240. Soil carbon sequestration, 45 to 100, biochar, 10 to 345, enhanced weathering, $15 to $200. By the way, some of these more natural ones that are used with human input, like the afforestation and reforestation, for example, and soil carbon sequestration, these actually have sequestered more CO2 than these other methods. Here are some other numbers. I thought this was interesting to look at. If you're looking at an industrial process with a highly concentrated CO2 streams, for example, what's coming out of a chimney or it's, from a power plant, it's going to be $15 to $25 per ton. If you're looking at something that where the CO2 is more diluted, like cement production, for example, and actually power generation is under this one, $40 to $120 per ton. And this is another estimate for direct air capture, and this was from 2019. It says $130 to $340 per ton, which is not far from what was estimated for 2023. So when we're looking at these projects, there's some things to know, and this is taken from the International Energy Agency. Around 45 commercial facilities are in operation right now, okay? And they're also storing the CO2. Oh, of these, 700 projects are in various stages of development, and larger capacities are now being announced. So the total CO2 that could be captured in 2030, and this is important to look at, is around 435 million tons per year. And this, I didn't catch this. It should not be MT. It's 1 million metric tons. So that's an error. I'll take that out before I send you a copy of the whole thing. They've announced storage capacity up to 650, and it's again million tons, not MT. So, but what's interesting to look at this is that this is just about 40% of the 1 gigaton per year, which is captured and stored in the net zero emissions by 2050 scenario. So in order to do this, we don't have enough capacity. It's not predicted that we're going to have enough capacity as of today. Okay. So also, right now they're capturing about 50 metric tons of CO2 annually. And that's like a drop in the bucket compared to the gigatons. Close to 10 large-scale operations are supposed to be in operation were supposed to have started in 2023. I'm not sure if they did or not. And the capacity for 2030 is increased since last year in their prediction. And it's just around 40% of the net zero scenario, which I guess I just stated earlier too. So when looking at direct capture, there are significant inefficiencies. Direct air capture seems like the nicest one. It's the cleanest one, right? Taking the CO2 directly from the atmosphere. But when you think of the fact that there are 420 parts per million in the atmosphere, that's a very small amount of air. So what you need to do is you have to have very large volumes of air going through these fans to be able to capture the CO2. They estimate that it's 300 times larger than the volumes that you would have from a flue gas stream, okay, to get the same amount of carbon dioxide. That's an insane amount of air. Also, when you're looking at this, the IEA net zero emissions by 2050 scenario, direct air capture technology are predicted to capture more than 85 metric tons of CO2 in 2030 and around 980 in 2050. So today we have 0.01 metric tons that is being collected. So there are 18 direct air capture facilities operating presently in Canada, Europe, and the United States. And the largest is only going to take out about 1 metric ton of carbon dioxide per year. So again, if you look at this, these are very small numbers relative to the amount of carbon dioxide that needs to be removed. So in summary, carbon sequestration and some associated terms were defined. The IPCC stance was contrasted to that of the oil and gas industry. I introduced you to the carbon budget and know that it's not exact. And I don't think that we're going to be able to meet it unless we really improve what we're doing. Various technologies were explained for capturing and storing or making products from CO2. There's a lot more to carbon sequestration, which I've shared here. This is just scratching the surface, but at least gives you an idea of what it's about. Relative cost of various technologies was summarized. You can see that it's very expensive to do this. Feasibility of carbon sequestration was briefly addressed. So I also have some recommended additional sources for you. There's the IEA database where you can look at what's happening worldwide. There's also the Smith School free data port that talks about the state of carbon dioxide removal. So if you want to find out more about these, I would suggest going to these sites. And also, if we're looking at Michigan per se, I was able to find that there are 2 sites in Michigan here. One is from Core Energy CO2. And look at this, it's an enhanced oil recovery site right here. And they have a capacity of 400,000 metric tons of carbon dioxide per year. And again, this is enhanced oil recovery. The second one, located in Western Michigan, actually in Filer City, Michigan. I had never heard of Filer City, but I'm sure some of you have. It's a biomass CCS project, and that we weren't able to get much information on that, but it's still in development, and that's why. If you look at this map, you can see this darker gray area in the mitten. This shows the storage capacity area, which is called the Base Island Dolomite. My first engineering position was with Michigan, Wisconsin Pipeline, and they would bring gas in year round because in the summer when gas wasn't necessarily being used, they would be able to store it in this area. Well, as gas and oil is depleted, there's more room to put CO2 into it. So that's all, folks. I hope you enjoyed this and got something out of it. And there's a lot more to see and know about carbon sequestration.
So if anyone wants to ask a question, they can simply raise their hand under reactions, and I'll call on you, and we'll go forward from that. Janice, let me kick this off by asking the question. There probably is a business case that can be made for enhanced oil and gas recovery if you're in that business. What are the ones that are being put up now, are they mostly public sector supported? So the various ones, I mean, it's a lot of money to build something like that. And I can't imagine what the business case would be for some of these at this point.
Well, if you look at the United States government is spending a lot of money now on incentives. Unfortunately, part of that money is going to the oil and gas companies, but they've found a way, to get it. The IRA covered part of this. I don't know if that fully answers your question.
Yeah,
There's
that's
a
what I was thinking.
That's
Yes.
it's mostly it. One thing I've read that if they start encouraging people with taxes on how much
Right.
CO2 is produced, it may,
Carbon tax, right.
you know, yeah, carbon tax, but do it. I
Yeah,
hope
they've changed it fast.
it does. And
Yes.
Wayne, or I'm
Yes,
sorry,
yes.
Mark, I should
No,
let you
no,
call
okay.
on people.
Wayne, go ahead.
Sure. These underground spaces where you can sequester CO2 that might actually come back out at you if you have a leak
Right.
can also be used for long-term compressed air storage, which I
Good
think
point.
is probably a
Mm.
better use of them as we move to electrification. We are going to have severe problems with probably and more use of electricity when we have less solar in the wintertime,
Right.
as is shown by the fact that 70% of what I generate on my net zero home goes on the grid because it's all made in the summertime when I don't need it for my heat pump. So, any
Yeah.
comments on that?
I think it's a great idea. What else can I say? If anybody else want to add anything?
I think it's a great idea. Okay, David Curtis, you're on.
Okay, thank you, Janice. It's an interesting discussion, and I hope this isn't outside uh, your knowledge base. Maybe, I don't know. It
We'll
certainly is.
see.
It certainly is outside mine. But is there any chance that there could be scrubbers or residential furnaces sold on a wide uh, basis? You know, so that hey, you need this. It costs $200. You know, it lasts for 2 years, and you will not put carbon dioxide into the atmosphere or
Yeah.
other stuff.
Well, I don't know if I can answer specifically for homeowners, homeowner size equipment, but I do know when I worked for Michigan, Wisconsin Pipeline that scrubbers are very, very, very expensive. Okay. And I'm assuming they would also be very expensive for, residential. And I don't know if I haven't seen anything. That doesn't mean it's not there because
Well,
again,
the federal
I'm
government has
this.
hardly been able to even make the
Pardon me?
electric
Right.
generating companies. They're supposed to use those things, but they don't put them in.
Yeah.
They don't buy them. They don't.
It's a good
What?
private conversation here with Marcia.
Oh,
Oh,
Sorry, go ahead. All right. Chuck, how about you? I bet you got a good question.
I do. Thanks, Mark. Janice, thanks for your presentation. Well done.
thank
I'm
you.
going to admit that on your last slide, you mentioned Filer City. I'm actually the chief engineer, and I could probably speak for a few days on what we're doing there.
Wow. Yeah, tell us.
It's a super cool project. You mentioned some of the price points on one of the slides. Obviously, we're targeting something far different than that. We're on the very lower end of the spectrum, which is great for the state, great for everybody. Couple points are that I think you were getting to, but didn't quite get there, which is even if we did all this carbon dioxide capturing, which is very expensive, and we were able to store this underground in a safe way, we're not going to make a dent. We've got to change the whole supply chain side, right? We've got to do something different to eliminate CO2 to begin with.
Yeah.
We've got to stay focused on that because we just can't do everything with a sequestration plan. We've looked at this holistically at Filer, and one of the great things we're doing is we're using what's called sustainable forest residues. So we're capturing the biomass that's going to the ground and not being used in furniture or paper, which would normally exhaust all of its CO2 back to atmosphere, or that it's captured. We're going to grab that, combust it, sequester all that CO2 that we've gathered underground permanently. We're not going to use EOR. We're going straight to sequestration. And then we're going to reforest state of Michigan because we're basically wanting to have a sustainable process here that ends up net negative CO2 from the atmosphere, because that's the end game. We have to eliminate CO2. Some great things. We're going to be making 40 megawatts of power that are net zero. So it's dispatchable energy. We can run around the clock and make renewable energy. Unlike solar, which we all love, and wind, which we all love, this is going to run all the time, which is really huge. And Mark, it's up by your cottage, which is also good for you. So there's lots of things we're doing at Filer City that I can share maybe in a follow-on presentation to take Janice's presentation to the next step. We've looked at direct air capture. We've looked at, to Wayne's point, using the places we're storing carbon dioxide for compressed air. You've got to be very careful with the geology. Certain areas we can do that and it makes sense, and we can go to compressed air as an energy storage device. We can also use the CO2 that we're putting underground actually as an energy storage device. That's a little more complicated, but it's something we're looking at. I just wanted to let the audience know that we're doing a lot on this space in Michigan.
Wow.
This is going to be the first one nationally that's actually a bioenergy, whole host bioenergy carbon capture direct to sequestration. We've already working on a class 6 well application in the state of Michigan. It'll be the first one so that we can safely store carbon dioxide in wells underground forever. It's a really cool project. I'll just stop there and just say, hey, we appreciate your presentation, and we're behind the scenes trying to make this all happen, at least making a small dent.
So Chuck, is there a solid business case for that project? I mean, is this something that people are, doing research on to see if it's going to work, or is there a solid case here? I mean, can you go to the bank and say, give me money, I want to build this?
Yeah, actually, it really makes sense because we have an existing plant. The plant right now burns coal. We can use the same equipment to burn biomass. So converting it and using it for another 30 years makes total sense. The embodied carbon is 0, right? We already got a plant. We don't have to build a new one. And we just happen to be 10 miles from where we're going to be storing it. So we don't have this dangerous pipeline. We have a very great case. Now, the really cool thing is, I'll just share this, is if we can make this work, and financially it is complicated, but it's going to be the first one, I'm confident. We've got a couple more biomass projects in Michigan right behind it. If we can make this work, we've got a legacy of projects we can do and really be a leader in the industry to make this happen in Michigan safely. So it's all about being safe. The well leakage is not going to happen. The pipeline is short, the risk is small. We have to stay focused on making sure this works, and we can't let this project not work because we don't want to derail the industry. So a lot of visibility on this. I could talk for a long time about Mr. Curtis's question locally on capturing CO2 at our furnace level. There are things called air source heat pumps and ground source heat pumps that are a better choice. We'd never be able to survive that. Right.
Anyway. And I should have mentioned that. I certainly know about that. Yep. Chuck, this is fantastic. I'd love to talk to you some more. My email is on the jmeans@ltu.edu. So please contact me and let's talk some more. And I'm really looking forward to hearing your presentation, which I'm sure Mark will set up as soon as possible. Right, and
then sometime in the new year, the first 3 months, would that work? We'll slot you in there. You let me know when it makes sense. And it'd be great to do that. That'd be wonderful. Yep. Other questions?
I wanted to add one more thing that if I didn't emphasize it enough, I think it's very, very important. It's critical that we reduce the amount of CO2 we're putting in. We need to stop doing that. Carbon sequestration is not to be done in place of doing that. It's to supplement it, because I don't think we can get rid of enough. And since CO2 has such a long tail, it stays in the atmosphere for hundreds of years, and we've put so much already in the atmosphere. That's why we need the carbon sequestration. Thank you so much, Chuck. Very, very interesting.
Yes, could you speak a bit, so from ASHRAE's point of view, that it seems to be other than the utilities, in some ways it's an almost unregulated industry. People are going out and throwing stuff up in the atmosphere to see what'll happen, and and there's I see a project with Israel's project where they were just throwing water up in the air in the ocean to see how much dropped down, and the people are doing stuff here, and it seems kind of scary when you stop to think about it. Russia's talking about putting big sails in the air and blocking sunlight, and I'm just like, wait a minute.
You're talking
Is
about
anybody in charge here?
yeah, you're talking about geoengineering, and carbon sequestration is considered to be part of geoengineering.
Yeah.
Other things that have been proposed, and actually even our government is doing research on, which scares me to death, is putting particles into the air to reflect the light, or
Right.
creating more clouds to reflect the light. And that, to me, it seems, well, let me give you an example. It reminds me of people bringing animals in to take care of a problem, and then the animal that they brought in, since it's not needed, causes a bigger problem for them. There are a lot of unforeseen consequences of doing some of these other techniques, and it is very scary. Wow. Yes.
Yes. So does ASHRAE speak to that in this books that you were working on? Do they talk about the dangers of
Well, actually,
uninhibited experimentation?
in the carbon, or excuse me, in the climate change chapter that will be issued in 2025, I had trouble finding someone to write on carbon sequestration. That's why I did my own research on it. And I did talk a little bit about geoengineering, just like a paragraph or two, talking about the dangers of doing it. So no, it hasn't been done in detail. There was a presentation, in fact, Jim, what's his last name? He used to be with Oakland University, and I know him well. Jim Lydell, who
Yeah, Jim Lydell.
I was hoping that Jim would be on today so he could correct any way I might have misspoke, because he really does know a lot about carbon sequestration. But what was I going to say about he's developing a technique, or starting a company, I think, which is producing hydrogen and solid carbon. He's looking for funding for that right now. He thinks it can do it.
Outstanding.
He's done amazing things. If you remember from previous talks, he what he's done to his house is just amazing. Some things that you would only expect in an industrial. Yeah, he's done to his house.
So in our last few moments, tell us about this award you're going to be getting in November, and who are some of the other awardees who have received that?
Well, I'm still amazed, and I should pull up on the internet. I don't know if I can do it fast enough. I'm still amazed and still pinching myself, because I'm the first woman engineer that I have seen in the list. And I am just awestruck with the people that have gotten it in the past. Gretchen Whitmer got it last year, for example, and Debbie Dingle is getting it also this year. They originally, when they called me, they said they were going to be 4 people that are alive getting it, because they also give legacy to people that left. So there are 5 now. And let's see, Debbie Dingle and me, and then the 3 others, 2 of them are attorneys or judges. And I forget what the new one, because I just found out about her there. But I just don't know what to say. I think that there had to have been some women engineers before me that were deserving of getting it, and no one apparently nominated them. But I just keep pinching myself, as I say, to get this award. And again, if I didn't state what it was, it's the Michigan Women's Hall of Fame.
Outstanding. Well, congratulations. And it's wonderful that I, not only a woman engineer, but a solar person. And I bet if you look in there, you're probably one of the first solar people too. So you kicked that glass ceiling open for several things. So excellent. Outstanding. I want to thank you.
Oh, okay.
Anyone else?
I was just going to add a couple of things. 2 of the women in there, when I looked through, really had a big impact on my life, but even though I didn't know them personally. And one was Andresen. She started Youth for Understanding, which was a way to get German children to come over to the United States to live with American families right after the World War II.
Wow.
create a greater understanding, youth for understanding. And I was an exchange student, not right after the war, of course, in 65, which made a big difference on my life. And the second person who did is Matilda Wilson, Dodge Wilson, who created Oakland University. And coming from a poor family, I would not have been able to, go to any place except Oakland Community College.
Yeah.
In fact, I only got to go to Oakland University because I got a full scholarship, but I could commute there. So I just wanted to share that.
Outstanding. One of the better alumni. So they know you're getting this award.
They're both
Oh.
passed away.
Excellent. Well, Janice, I want to thank you so much for coming on.
Thank you.
You've got to start in a good direction, and we'll have Chuck come in, and you can help me work with Chuck when we get him there and figure out what kind of questions we want him to ask him. Because he's right, Chuck can speak for 3 days on this topic, and we got to squeeze him into an hour, which he always works very hard with us to do that. He does it. It's amazing to me.
Looking forward to it.
Looking forward to it. And Wayne, thank you for your good questions, and all of you. And come back next month for the last session in 2024. Reverend Charles Morris, one of the founders of the Michigan Interfaith Power and Light, will be giving a presentation on the Pope's encyclical on the environment, what it is, what it says, and what difference it's making. So I think that would be a good thing. Madonna University, where Charles is the lead resident and head of the religion program there, is doing quite a lot these days. And so he's right on top of this stuff. So it's good stuff. So I hope to see you all then. Till then, remember to vote. Bye, everyone.